On two previous lessons, we spoke about the functions. Let me very briefly consider what we are talking about. The function is some sub-program, subroutine that has a name, that has a return parameter, and that has a list of parameters. Type of the result of the function. Res type means that the function returns some value after its execution, and this value must be returned using special statement return, and this statement immediately interrupts the function execution. Okay. Let's consider some example of the function. We consider several examples on previous lessons, and let me consider it again. For example, double sum, double x, double y. It means that this function has name sum. It should returns double, and it has two parameters, x and y, of the type double. And here I should write at least one return statement. Return x plus y. After that, suppose that I have two variables, for example, a equals to 1, b equals 2, and I want to perform this very complex operation a plus b. I want to compute the sum of these two values, but this sum I want to compute using the function sum. There are two possible options. First, maybe the best is to create some variable, and after that assign to this variable the value that the function returns, and after that returns this value to the screen, output this value to the screen. Well, after that we see on the screen sum of these two numbers, a and b. I run this program, yes, and we see that the sum equals to 3. Let's consider again some features of functions, and let me write here one more return statement. I repeat that inside the function I can write a lot of return statements, any return statements that I want. It depends on the problem. But suppose that I write here two returns. Return x plus y, and after that return 0. What will we see on the screen in this case? How do you think?
There'll be an error.
Error.
Oh no, there'll be 0. It'll be 0.
Two answers. I hear two answers: error and 0. Maybe
not error. I think it will return
0.
0 because
returns 0.
Yes.
Okay. Do other students have another suggestions?
0.
0. Okay. First of all, let's try. What? So, sorry.
0 or 1?
0 or 1? No. All your answers are wrong, unfortunately. Well,
it will be x and x plus y.
But what will we see on the screen?
Just a normal answer.
3.
3.
Yes.
We will see 3. Let's discuss why. First of all, let's try to compile this program. And you see that the program is correct. I can write several return statements. I can write several return statements, but the main feature is that the return statement immediately interrupts the execution of the function. If you write return x plus y, the execution of the function will be stopped here. I can write here, for example, let me write here some message. Message from the function. Just a line to the screen. Message from the function. We will not see this message on the screen because I write this message after return. If I run this program, I see the result sum equals to 3. Only the first return will be executed. Suppose that let's write another method. Message after return and message before return. Before return. The message before return, we will see this message on the screen.
Did he leave?
Are you guys also like muted? I don't hear anything or see anything.
He's not
Yeah,
here.
it just cut off. Like,
Ah, he's back.
Okay, do you hear me now?
yes, sir.
Yes, sir.
Yeah. Well, sorry, my computer decide that it's time to reboot without my help. It's just reboot. Well, I see that the meeting still be recorded. Very good. Now I start Visual Studio again. I open this example. And I open the presentation. Please wait a minute. Well, next time I will send you the link again to be sure that you use a correct link.
Yeah, sorry, that was our mistake.
Wait, where is the presentation? Presentation is here. Okay. Well, and share the screen again. And well, we write two messages, message before and after return. After first return and before first return. The program still be correct, and we will see on the screen only the message that is before the first return. If I call this function again, suppose that I write here again, I can call this function with different parameters, like this, or even like this. I will see the messages before return. I call this function 3 times, 1, 2, and 3, with different parameters. And I will see 3 messages. Message before first return. The return statement, it interrupts the function execution and transfers control to their main function. That's why if I put this, for example, return 0 at the beginning of the function, in this case, what will we see on the screen? Will we see?
Yeah, it's a useless function. Nothing will show. It will just say sum equals
this message. Will we see this?
No, we will not see that.
No. What will we see here?
We will just see sum equals, and then that's it. Nothing. I don't think there should be a value assigned to it.
0. returns 0. I return 0. The return statement returns as a result of the function 0. And I see here the message that sum equals to 0.
No, not 0, just nothing. Right? Oh, 0. Okay.
0, not nothing. Because I write here a value 0. Well,
Yes.
The return value depends on the expression that I write here. Suppose that I write here just 2. What I see on the screen?
Sum equals 2.
Sum equals 2. Okay, if I write here something like this, x plus 5, and I call the function with these parameters, what I see on the screen?
Sum equals 7. No.
7.
So x is 1,
8.
and then 6, right?
6. Right. 6. The order of parameter is important. The first parameter is a, and it equals to 1. Second parameter is b, and the second parameter equals 2. And I write here x plus 5. And I see on the screen 6. Okay, if I write here such call of the function, sum 5 and b, what we see on the screen?
7. Sum equals 7.
No. No.
It's 5, which is the x. Which
5
is
is the
10.
and
x.
then
10.
plus 2.
Of
No,
course,
it's not plus 2.
10. The expression is x plus 5.
Oh. Yeah. I forgot about the return expression.
First parameter is 5. And we will see on the screen 10. Well,
Okay, I get it.
do you have some questions about this very simple example?
No, sir.
No. Well, and this example shows you one more very important feature. This feature is written here, that parameters in the header of the function are not real information objects. They are used just for organization of data interchange between the program and the function. So these parameters can be considered as a gates through which calling and called program communicates the data. So when I write here x, I don't declare here a variable x, because actually the variable is a with value 1. Let's write here x plus y, and x and y are called formal parameters. And when I write here in the main function sum a and b are called actual parameters. Again, these parameters are called formal. It just indicates that this function must get to values of the type double. And actually, I pass to this function the variables a and b. X and y are formal parameters, a and b are actual parameters. Well, these we already consider. I come back here later. We discuss about the prototypes and well, okay. Let's start from this slide. Information interchange. You see that the function, subprogram, subroutine, and the main program, main function, exchange information. And the function implements some part of the algorithm. This part may be very simple, like in this example, because here the algorithm is extremely simple, just x plus y. But from the point of view of information processing, the function must get initial information from column 1, process this information, and returns the result. And for receiving data, the list of parameters are used. In the list of parameters, we describe what information objects and what types of the object we should write when we call the function. But again, the elements from this list are not real variables. The real variables are described in the main function. So x and y are not real variables. The real variables are a and b, and I pass to this function a and b. And I can call this function, and I can pass to this function other variables. So here formal parameters x and y still be the same, but actual parameters here are s and s. I change the actual parameters of the function. So when you call the function, you must write here actual parameters. Well, now how to return the value, how to return the result of the function from this subroutine to the main one. If this value is only 1, it can be returned by means of the statement return. Just return this value. Write return x plus y, and that's all. But suppose that we should return several values. For example, 2 or 3 or 4. But usually we consider just some small amount of variables, values that we should return. If we should return more than 4 values, it's better to return it in the form of array. We briefly considered it on previous lesson, and we will consider it one more again, maybe today or next week. In this case, we can use formal variables as well, but in some specific way. All the parameters can be divided into two groups: entry or in parameters, through which the function gets initial information, and exit or out parameters, which contain the results obtained by the function. And there are no special constructions defining whether a parameter is in or out. Everything depends on type of the parameter, which defines the way of data interchange. If a parameter is just a variable, is not a pointer or reference, then a copy of actual argument is transmitted into a function. For this local copy, the memory is located inside the function, and the function operates with this local copy. It means that the operations of the function cannot change the value of actual argument. Such way of data transmitting is called passing by value. This method is the most appropriate for entry parameters, because function cannot spoil actual arguments. Let's consider this method of passing parameters to the function in details, in example, in Visual Studio. And let me write a very, very simple example. Maybe more simple than this function. Let me write the function func void. As far as the function is void, I should write just return without any parameters. Let me remind you that the type void means that the function returns nothing. No value should be returned by the function. Well, now let me delete all of their functions. Sum, okay, and I output just the value of the variable a to the screen. Well, let me delete these two lines, it's from the previous example. Well, I extremely simplify my program. In this case, what I see on the screen, it's very simple.
A equals 1. Yeah, A equals 1.
A equals 1. It's a very simple question because I do not change the value of A. I just assign A to 1, and after that, just output it to the screen. Well, now suppose that I write in the function such expression: x equals to x plus 1, or I can do the same, just to write x plus plus, right? Because plus plus increase the value of the variable. And suppose that I call the function here with parameter a. Now, what will we see on the screen?
2.
I think still 1, right? Because you said The return void doesn't it doesn't change. It doesn't return any value.
Yes, the function doesn't return any value. Yes, you're right. You're right. But I can change it. I can change the situation. Okay, let me write here double, and let's return x.
Yeah, then it's 2, I think.
That's 2.
A equals 2.
Okay, let's check. And we see 1. A still be 1. What happens? Why? Why we see 1? Why not 2? Let's consider how it works. And let me print here let me write here to output message x plus plus output x after plus plus. And also let me write here two messages, the value of a before function call a after function call. Just for 4 messages. First of all, let's discuss about the order of messages that we see on the screen. What will be the order of messages? First, we will see this message. After that, we will see these, and this, because I call the function between these two messages.
Ah, yes.
Okay, and what will we see here? A before a function call equals to 1. Well, after that, I pass a to the function, and x will have the value of a, 1, x before plus plus, 1, x after plus plus, 2. So the value of x is changed, but the value of a, the value of initial variable, still be 1. Well, and let me write here one more variable s, and s equals to func a, and output the value of s. S equals to s. What is s? What will be s? S will be the value that this function returns. This function returns the value of x after plus plus. So s will be 2. And the main point is that the value of a, the value of actual parameter, is not changed. Why this situation happens? It happens that because here I want to outline here. Yeah, a copy of actual parameter is transmitted into the function. Not the variable a is transmitted into a function, but some temporary copy of a. and the function cannot change the value of actual parameter. I can write here any operation that I want. It cannot change the value of x. I can write here x equals to x plus 100. This operation changes the value of x, but it cannot change the value of a, because a copy of a will be transmitted here. So we see that a before function call 1, x before plus plus 1, x after plus plus 2. Then I don't output message here. 2 plus 100 is 102, and this value will be returned, and s will be 102, but a still be 1.
Oh, okay. That's why it's important to create a variable for the function.
Yeah, do understand it? Okay. Well.
Yes.
And a good example is the function that changes the values of two variables. And let me delete these lines. And let me delete. Okay, let it be. How to change the values of a and b? Suppose I want to change the values of a and b.
By reference.
I can do it with temporary variable. For example, this variable s equals to a equals to b, and b equals to s. These three operations change the values of a and b. And suppose that I want to write a function that gets two values, x and y, or even I can call it a and b. The function change double a.
You said this is called like a swap or something, right?
Okay, yes, we can call it swap. And I can put here these lines. As you see, s is declared in the main function. Here, in the function swap, the variable s is not declared, so I must declare it here one more time. And pay your attention that this variable s and this variable s are different variables. This s exists inside the function. This s exists inside main function. Well, let's call the function swap with the parameters a and b. Let's output to the screen the values of a and b before the function and the values of a and b after the function. the initial values of A and B are 1 and 2. Let's run this simple program. And we see that A and B still be the same. 1 and 2.
Is it
1.
because you didn't return anything in the function?
No, no. I can write here return statement. Again, I can, for example, I can write here double swap and return A plus B, like this. But A and B is the same, 1 and 2, 1 and 2. This can be deleted.
Oh, you need to create a variable and assign in the main body. I think you need to create a variable.
Wait a minute. No. The main feature, the main point is that these A and B and these A and B are different variables. These A and B are actual parameters, and here A and B are formal parameters. I can use any name that I want. For example, I can write here X and Y. Let me write here X, and X equals to Y, and Y equals to S. These A and B, when I pass it to the function swap, X and Y will be a copies of A and B. It's not actual A and B, but a copy, some different variables with names X and Y that have the same values. X will be copy of A, Y will be copy of B. And if I change the copies, their original variables still be the same. But if I output X and Y in function, these values will change, and we see that X, the first value, will be 2, and the second value will be 1. 1, 2, 2, 1, and again 1, 2. So inside the function, these values are changed, but outside of the function, these values will be the same. Do you understand this main feature?
Yes. It just kind of seems like it defeats the purpose and kind of makes it not as useful. I don't know how you could benefit from it if it's not changing the actual main program.
Well, now, if you understand it, now I show you how to write a function that changes the actual parameters, because this is the next main point. And how to write it? We should pass the parameters by address using pointer or by reference. Maybe passing by address is more complex. I consider it maybe next week, or maybe in the end of this lesson. And more simple way is to pass these parameters by reference. we can use a reference as a function parameter. In this case, reference to the actual arguments is transmitted into a function, and function gets access immediately to actual argument and can change it to. Such ways of transmitting is called passing by reference. Thus, using references, we get the possibility to return data from called function to calling one. How to change, how to write the parameters. From the first point of view is very simple. You should just write the ampersand sign after the data type. Here's the function change. I can write it as a swap if you want. Swap xy. Here it's right in my program. I write it as double, but it doesn't matter. But the main feature is that I should write here the sign of the ampersand after data type. Let's do it. Very simple construction. Just write ampersand. And in this case, all the changes that we made inside the function, we can see it from their main function too. The values of a and b will be changed. Let's check. 1, 2, and 2, 1. Well, you can ask me, but what is a reference? What is a reference? Some things about references is written here in the presentation with pointers. Let me come back to this presentation. I skip these slides, and here are just a few slides of references. From the formal point of view, reference is a special variable which is not a real variable, but just a pseudonym for another variable. I can say that the reference is just the second name of the other variable to which it refers. The actual variable is only one, but when I create a reference, this one actual variable will have two names. First name is the name of this variable, and the second name is the reference. So p-var here is identifier of a variable. Ref is a reference, and after that, ref and p-var are different names of the same variable. Let me show this concept in example. I comment this part of the program. I exclude temporarily this part, and I try to explain the notion of reference. Suppose I create a reference ref, and this reference refers to A. Now it means that the actual variable is A, but this variable has two names, A and ref. All of these names correspond to the one variable. Suppose that I write ref plus plus, and I output to the screen the value of A. What will we see on the screen?
A equals 1. I mean 2, sorry.
2.
Right, 2.
2, да.
Because ref and A are the same now. Is just different names of one variable. You see A equals 2. I can carry out here any operation. For example, ref equals 10. Just assign 10 to this reference. Again, as far as ref and A are just the different names of one variable, A will be 10. A will be 10. I can write any operation that I want. For example, ref plus 1. What will we see on the screen now?
Again, A equals 2.
2, right? Because ref, the initial value of ref is 1. And vice versa. For example, I write here A equals 10, and I output to the screen the value of reference. What I will see on the screen?
You'll see a ref equals 10.
10, right. Well, this example, I want to show you the very simple thing, that ref and A are the same.
Ah, yes. Just like a nickname.
Just different names of the same variable. Well, and the sign of the ampersand that is written after the data type inside a declarative statement corresponds to declaration of a reference. Reference must refer to another variable. Well, and here I use the reference. I use the reference in declaration of a function. What does it mean? It means that x will be not another variable with the same value, but x will be just another name of the variable A. And all the actions that I carried out with x, all these operations influence to the value of A. And the same for B, because y will be just another name of the variable B. Well, passing by pointers, yes, you can. And of course, we discussed about passing by pointers. Maybe not this week, but the next lesson. Well, do you understand this feature?
Yes, sir. Yes, I get it. So if we want to actually influence the main program, we should pass by reference. So that
Right,
it's not
right,
just
right, right. If you want to get from the function two variables, two values, you should just pass it by reference. And after that, you get this result to the main function. And you can see it in the main. Well, okay. What happens in this case? Suppose I pass the first parameter by reference and the second parameter I pass by value.
Then
What I will see on the screen now, the initial values are of A and B are 1 and 2. But what will we see after the function? How do you think?
2, 2.
I'm not sure. Maybe it's gonna stay as in the same order because you need both A and B to complete the swap.
The correct answer, I hear the correct answer, 2 and 2.
Yes.
The correct answer is 2 and 2. Why? Why 2 and 2? Look, the first parameter is passed by reference. The second parameter is passed by value. It means that all the changes in the first parameter, we will see it in the main function. But the second parameter will be passed by value. The copy of actual parameter will be transmitted. And we will not see the changes in the second parameter. That's why the first parameter will be changed. A becomes 2, but B still be 2. We will not see B as 1. B still be 2.
Okay.
If I change the order here, first parameter will be X by value, and the second parameter, Y, is passed by reference. In this case, after the function, we will see 1 and 1. 1 and 1. Because now the second parameter will be changed, but the first parameter still be the same, 1. Do you have some questions about passing by reference and passing by value?
No, sir. It's very clear.
Well, the function swap or change is a good example. Is a good example of passing by reference. Well, I think maybe it's enough for this lesson. Next lesson, we consider the last way of passing parameters, passing by address. And we discuss about passing arrays to the function, connection between the ways passing by address and passing the arrays to the function.
Okay, got it.
Well, now I stop recording.